In this video today we're going to look at how the electrons are arranged in the shells of atoms. You need to know for GCSE the electron arrangement for the first 20 elements. But I wouldn't sit down and spend ages and ages and ages learning them. I would, if I were you, try and spot the patterns. Anyway, let's have a go at this and see how we get on. A key rule to remember is that the first shell, which is closest to the nucleus, can only hold 2 electrons. The second shell can hold a maximum of 8 electrons. And the third shell can hold up to 8 electrons as well. Although my pants are slightly on fire through saying that, as you'll find out if you go on and do IB chemistry. So you need to remember that the number of electrons is the same as the number of protons in a neutral atom. So here you can see we've got the first 10 elements all lined up. And if you have a look, hydrogen is already done for you. Hydrogen has an atomic number 1. It has 1 electron, and that goes in the shell closest to the nucleus. Helium. Now it's up to you whether you want to edit the spreadsheet or the version of this I've put as a worksheet for you or print it out. Entirely up to you. But helium has 2 electrons, atomic number 2. So they both go in this first shell. You can either write them next to each other there or opposite each other. It doesn't matter. The next to each other is a more accurate picture of what goes on. So helium, 2 electrons in that shell there. Now lithium has atomic number 3, so it has 3 electrons. We know the first 2 will go in that shell there. But once that shell has 2 electrons in it, it is full. It can't take any more. So the third electron for lithium has to go in this shell here. So we would write the electron arrangements of those 3 atoms so far in shorthand form as just 1 for hydrogen, 2 for helium, but lithium, now we're on to 2 shells, we would write as 2, 1. Now beryllium, atomic number 4, has 2 electrons in that first shell, 2 electrons in the second shell. And that would be written as 2, 2. Okay, I won't make any jokes about that being a ballet dancer's favourite element. Now, boron, atomic number 5, 2 there, and 1, 2, 3 in the outer shell. So 2, 3 would be its electron arrangement. Now, it doesn't take a genius, which is why I can do it, to work out, therefore, that carbon here must be 2, 4. 2 in the first shell, 4 in the next shell. 2 pairs or spread around really doesn't matter. Nitrogen, 7 atomic number, 2, 5. 2 in the first shell and 5 in the second shell. Oxygen, 2, 6. I think you can probably work out the pattern by now. Fluorine, 2, 7. 2 in the first shell and 7 in that second shell. Neon, 2, 8. 2 in the first shell, 8 in that second shell. Again, spread all around or in 4 pairs, it really doesn't matter. Now, you may remember, or maybe not, that 8 was the maximum that this second shell can hold. So have a think about, pause the video, have a think about what might happen for sodium. Sodium has 11 protons, so 11 electrons. How do you think they might be arranged? Just pause the video briefly and have a think. Well, here we are, the next set of elements, up to number 20. Sodium here has 2 in the first shell, 8 in the second shell, but 1 in the third shell. 2, 8, 1. Okay, it's not 289 because this second shell can only hold 8 electrons. So magnesium 2, 8, 2, 282. Aluminium 2, 8, 3. And so on. And again, it doesn't take a genius to work out, which is why I can do it. Phosphorus 285, sulfur 286. Yes, Harry, I know. Chlorine 287, argon 288. Now for GCSE purposes, once you get to 8, that third shell is now filled right up. So what happens when we get to potassium? Well, we need another shell. And we get 2, 8, 8, 1. 2, 8, 1. And then for calcium, 2, 8, 8, 2. Okay, that's relatively straightforward to do. If you're a little unsure, then please search SD Harvey Quizlet and you will find some Quizlets on Electron, or a Quizlet on electron arrangements. It won't show you the sort of target diagrams here. It will show you the shorthand version 2, 1, but it will give you a chance to practice them. And also, I'd like you to have a go at a crossword that I'll give you a link to within Google Classroom. Now, one of the most important things is, or to help you learn how these go, is to look at the periodic table. And what I want you to do is I want you to look at lithium, sodium and potassium. What group of the periodic table are they in? How many electrons do they have in their outer shell? Look at fluorine, chlorine. What group of the periodic table are they in? How many electrons do they have in their outer shell? Can you spot a link between the group number and the number of electrons in the outer shell? Have a look at helium, neon and argon. What is special about them? What can you tell me about the outer shell of those 3 elements? Have a look at the periodic table again and see if there's a link between the number of shells that an element has and the horizontal row it is in the periodic table. So have a look and see if you can spot those patterns. If it helps, feel free to cut these squares up. No, they're not squares, are they? These rectangles up and form your own sort of mini periodic table out of them, and then maybe stick that in your book. But please try and answer those questions I've given you in your book. They are important. They're something we'll touch on quite regularly a little bit later, but just to get you thinking for now. So in addition to this video, there is a version of this that you can either edit online if you're good with putting text boxes with X's in onto a slide, you'll be fine. If not, feel free to print it out and draw the X's yourself. Okay, so have a go, see how you get on, and feel free to make use of the Quizlet. There are all sorts of other things online, including a video on my website which will go through these electron arrangements with you. Okay, it's fairly straightforward once you get into it. Often people panic, and then by the time they've got to magnesium, they think, oh yeah, it's easy. Why didn't I get that to start with? Anyway, good luck.